Hello, I'm Saeed Muhammad Usman, and this is our group project report. Our project title is Review on Water Waste Treatment Technologies of Groundwater. We consist of three members, Ahmed Azwan, and me, Saeed Muhammad Usman, and Muhammad Kamalul Abram bin Uthman. So this is the introduction. We are talking about what is wastewater treatment and groundwater. So wastewater treatment is the way towards changing of wastewater that is discharged or is not usable for use again into bilge water that can be released again. Distinctive stages or sequences are embarrassed depending on the various nature of the water and its planned last use. Groundwater is the water that is held underneath the ground's surface in microscopic pore spaces. It occurs between two zones figure which are the upper unsaturated zone with of the most space filled with air and a lower saturated zone with all of the spaces filled with the water. Rainwater running over the surface naturally becomes groundwater. The water, on the other hand, continues to run through the soil until it hits saturated rock. They are also known as aquifers since they are made of gravel, sand, or sandstone and are found under the soil. How does groundwater move? Pores in the soil rocks are saturated with water at a certain depth, but can be shallow or deep depending on the situation. Water penetrating into the soil is absorbed by the soil particles. As shown in the figure, the rate of water flow depends on the surface area of an aquifer. If the topsoil is porous, water can penetrate the ground through a process called penetration. From the top surface, water flows through the contained material. When the plant runs out of water, it enters the environment in the form of vapor. The groundwater level may rise due to geological conditions such as heavy rain. The groundwater level is at top of the saturation zone, also found in the ground underground water level zone.
Problem statement: large percentage of human population depends on groundwater for drinking water. Groundwater is also one of our most important sources of water for irrigation. Unfortunately, groundwater is susceptible to pollutants. The high concentration of ferrous ion in particular exceeds the Malaysian water quality standard and index those. This is example of man-made contaminants like burning oil, so gasoline, salts, and chemicals. Effective method is important to guarantee that the ferrous concentration in groundwater can be decreased to a controlled rate. The best alternative water treatment procedure should be implemented to ensure that the quality of groundwater is in good condition and safe for human consumption or agriculture operation. Okay, for the next part is literature review. We do some research about groundwater, ion pollution in groundwater, water treatment, ozonation with limestone absorption, and groundwater treatment using dilation and ceramic filter. Okay, for the part groundwater, groundwater fills the vacuum spaces in the soil and geological layers, frequently referred to as underground water to distinguish it from surface water. Melted snow and rain soak into the earth, forming groundwater. In porous surface materials like sands or gravel, 50 to 60% of rains and snow melt and can seep into the ground. That's for the iron pollution in groundwater. Iron, which is known as ferrum, is a natural metal found in soils, rocks, and minerals. Iron is also a silvery white, malleable, ductile, malleable metallic element. Ferrum iron is believed to be ecologically necessary, but large amounts can cause ecological and physiological problems. The increased iron content poses a risk to human health by causing nerve damage, pulmonary embolism, bronchitis, intoxication, and Parkinson's disease. High ferrum concentration are manifested in stains during washing, orange and unpleasant taste during drinking and cooking. Water Water treatment is the process of converting raw water from above ground or underground water sources into a drinking state suitable for drinking and other household use. Next, for the part ozonation with limestone eruption. According to the World Health Organization, nearly 1 billion people do not have access to safe drinking water, and much of this water is contaminated by the presence of high level of heavy metals, which are found in melting of the earth. Ozonation is highly oxidized AOP, one of the most successful methods of groundwater treatment. When ozone, along with other molecules of oxygen, decomposes in water, it creates free radical called hydroxy and hydrogen peroxide. These free radicals are highly oxidizing and are involved in the disinfection process. The advantages of using ozones are improved sterilization properties and high oxidation capacity with short response times. In addition, ozone can be used to destroy organic and inorganic compounds, and it can eliminate taste, odor, and microbial processes. Groundwater treatment using dilution and ceramic filter. So, dilution and ceramic filtration are new technologies that can be used to improve groundwater quality by supplying and dispensing water to consumers. Dilution and ceramic filtration are complex treatments that made through dilution and filtration using rainwater. Okay, this method can also analyze the parameters of pH, dissolved oxygen, turbidity, manganese, chloride, sulfate, and fluoride without interfering the stability of other parameters. Ceramic filtration is the use of porous ceramic, which is calcium clay, to filter bacteria or other contaminants from drinking water.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hassan Azwan. I'm from Group 7. Today I will represent Chapter 4 and 5. Chapter 4 Methodology. Source of groundwater. Groundwater is the water present beneath Earth's surface in soil pore spaces and in the fracture of rock formation. It is stored in and moves slowly through geologic formation of soil, land, and rock called aquifers. It is found from following sources. First, meteoric water. It is the main source of groundwater. This water is received in the form of rain and snow. Second, condensed water. Water contained in pores and cavity of sedimentary rocks under seas and lakes is called condensed water. Third, magmatic water. Hot magma enters rock due to volcanic action, after which thick vapors, rock, are condensed and converted into water. It is called magmatic water. Water demand. First, domestic, industrial, institutional, and commercial water demand, as well as public usage, fire, and losses demand, can all be classified as water demand. While designing the water supply, the water quantity must be determined based on the city needs. Third, The formula for calculating per capita demand is as follows. Per capita demand equal to Q P times by 365 liter per day. Engineered water system. When the groundwater is treated, it is delivered to a water distribution system that classifies the amount of water needed for various purposes such as household or industries. For household wastewater will then be sent directly to the wastewater treatment plant, while for industrial wastewater will require pre-treatment before being sent to the wastewater treatment facility. Grit removal and screening. A grit removal technique was used before the primary sedimentary process. Screening is a process that refines the suspended material found in groundwater. The screening procedure includes a coarse screen to keep a large object out of the treatment conveyance system and a fine screen to keep small objects out of the pumps and other equipment. Aeration. The fundamental purpose of aeration, whether utilizing a cascade aerator or diffuse air aerator, is to introduce air into the groundwater. The specific aim of aeration are to reduce the odor and or taste of the groundwater, oxidize Fe and Mn, and dissolve oxygen to the groundwater. Selection of groundwater treatment process. MIEX resin water treatment process is the first proposed groundwater treatment method, with MIEX stand for magnetic ion exchange. According to the process, the resin can reduce the coagulant dose required for Fe ion removal in groundwater by 50 to 70%. To reduce Fe ion in groundwater is the simplified method for groundwater treatment using dilution and ceramic filter. Ozonation with limestone absorption is one of the most effective process to remove 70% of Fe ion. Chapter 5. Discussion. Selected treatment process. The impact of high Fe grouping will exceed the drinking water quality measure standard amount caused by Fe in the groundwater. Therefore, the most effective groundwater treatment is ozonation with limestone absorption. Ozonation process. Ozone is a solid oxidizing agent that can be used to remove bacteria, inorganic particles, and natural pollutants from surface or groundwater. It acts as powerful sanitizer in drinking water and creates a protective layer of UV radiation by passing oxygen via UV light. Ozone breaks down in water within the site of hydrogen peroxide (HO2) to make the hydroxyl revolutionary OH, which is the most grounded oxidizer accessible in the treatment of water. Absorption process. Pollutant can also cause an unpleasant taste or odor, as well as discoloration and health effects. The proficient method to diminish the centralization of the disintegrated colors in the profluent that is subsequent in the end of the shading is by absorption process. Limestone absorption process. The combination synthetic and actual cycles can get rid of the mix that give water its color, taste, and smell. As a permeable media, a retentive medium such as limestone has been proved to be a choice for treating Fe ejection from groundwater. Combination of ozonation and limestone absorption. The combination of ozonation and limestone absorption can improve groundwater treatment effectiveness. Since limestone is a low-cost absorbent, it can reduce the amount of ozone used in groundwater treatment that can cost us a higher operational cost. Okay, that's all from me. Thank you.
In conclusion, groundwater is one of the natural resources that must be protected from pollution. Existing iron concentrations deteriorate the quality of groundwater, making it unstable and unusable for human consumption or agricultural purposes. In the case study showed that the groundwater problem was caused by iron concentrations exceeding Malaysian drinking water quality standards. By referring in our result and discussion, the most treatment in the ozonation process with limestone absorption. where the limestone as a low-cost absorbent can minimize the amount of ozone consumption during the treatment of the groundwater. However, if the treatment of groundwater simply uses ozone as a parameter to solve the problem, the high dosage demand will be expensive.